Welcome back. So, in the same fashion of my last day, God damn it, situation is the same from the last day, as in we are still stuck with this small problem of having not accessing every single position. And one thing that I want to check, one thing that I want to check about my one thing that I want to check about my logic is to actually draw everything that I touch every single time. So maybe I can get an understanding on how the algorithm operates. So that would be I guess I would want to put okay, let's start with the came from. Let's make a copy of the map. The visual and there you go. By the way, this also answers my doubt that if you if you equal it, will this be an automatic clone? And it looks like it would. Right, so my visual will then, every time that I want to put in the came from, this should show what's happening, right? And at this point, visual nine.0, 9.1 equals, let's say, the visited, and that would be current. Got borrow visual as mutable. Let's pretty print it. Okay, so I get a coffee break instantly. I'm confused. Either my bot is not working how I intended to, or I do actually get ads in the same manner. Okay, so it does look like we take a look at everything. So this is nothing but this is nothing but a problem of that is finishing now. So my ad is done. All right. Fuck, why is it unstable? Okay, very well. So it looks like my algorithm does find everything. Wait. Hmm. So yeah, I'm gonna try to eradicate the idea of adding multiple instances inside here and just move it forward over there, because I don't see how I can check any other way the difference. So came from should have a vec of coordinates. Now this would get absolutely pissed, because if it's nothing, I would simply put the vec. Otherwise, I'm going to push the current. So by this change, I should be having every possible path coming backwards. Oh, you see that the bagger one is not amazing. Came from for print new arm ele. So it doesn't look like I swear that I was able to do something like that. I kinda remember I was able to. Oh no, wait. There's one here. There should be at least two alternative ways to go about it. Shouldn't there? Because again, I'm moving in every direction. Like that's the confusing part. Actually, by the way, I don't, because there's this path that never gets taken. Which is one of the which is one of the problems. There's a map on the way up, but on the way down I keep trying to compare the scores. Second part is done by backwards PF, so touching from the end and going backward every time. Check. With the help of two gentlemen, I was able to solve this day with a poor man's backtracking algorithm. The code is what it is, but I'm so happy finally we got this. I know it's a lot of people use the extra algo, but I insist on doing it with kind of DFS style. I'm thinking that there must be a shorter way to solve it, but after 4 days of bashing, I'm just happy to have that work. A lot of coding effort for 50-55 runtime. Oh my lord, how many... The fuck, this dude? The fuck? Yeah, I'm looking at that. Okay, to this another stamp, this doesn't work. It's best it's nearly identical logic to the social schema. The up here is wrong. Out path. A variable contains all paths. Day 16, part 2. Yeah, well, at this point I'm so close to just... You know what, today I'm going to do just a BFS, check every single path possible to get there and simply calculate how much it takes. Although I wish, honestly, I wish to make the extra work, or a star, whatever. Sorry, it's day 20, not 16. Dude, edit the fucking Python all days in less than 1 second. Why is this approach work? Hope you're doing okay. Like my first time properly, I'll see. Check this well-educated guess. Checkpoints, path -1, less than. Check out what well-educated guess was running my code after testing operating accounts. It works on all of them. I don't know. It's just lack of approach. After coding, I saw Neil Tasman resolution and was able to understand Dijkstra plus heap approach. While it appears to be correct way of solving this problem, but the doubt about resolution persists nevertheless. CMake. Rick, thanks for the lanternfish. Solve this in under 1 millisecond. Advent of Rick. I was supposed to implement iSearch and find the path really fast, but I cannot find the my issue is my exploring set. I was able to do the same example using a function that turns the whole path from my current element in queue instead of exploring set. I work on Java. But I want to work on my input. If you're missing something, a simple way to do it, like always, was it? What is it? Sorry, my poor English. Thanks in advance. Well, I keep finding this. X value is in the visited set. The cost I traverse the location in the given direction. If I already explore the location for lesser cost, I discard the branch. Don't expand the value visited and continue search. Just do a star with an additional option. First, find the first best route and process the queue until there are no elements left. You find a path and its cost the same as the best, add it to the found list. This was how I did. My visited set isn't just a hash set of points. It's a hash map associating each point to a direction with the lowest cost I've seen for that point. I think you're really close. What you need to change your handling explored set in order to determine if the path you are is one of the best possible paths instead of the first of that location. Yeah, I got it. Thanks, mate. So the problem is not in my came from, the problem is in my open set, which is simply a path. Ugh. One thing that I believe will simplify my code without changing most of its meaning would be removing the F-score. I don't believe that the F-score provides me with anything really. Like, I might be wrong, but so basically at this point this is the extra. Okay, now the F-score does give me the correct path, so it shall remain. Okay, very well. So by keeping an extra value in the visited set, the cost to traverse the location in a given direction. I have already explored that location. With a lesser cost, discard the branch. If not, replace the value visited and continue searching. Just I start this additional option. Find the best route and process the queue until there are no elements. If you find a path that its cost is the same as the best, add it to the found list. Yeah, but by path. First off, this doesn't work, by the way, because I don't look up this possible path. Where I don't. It took a bit of brain approach with the data structure of O1, shampoo implementation. Then just had every item in the search queue carry around the entire path, which led to that point. The ones that various ads to achieve the minimum score, just connected each of their path nodes it also. At the DFS, Stocky helped to calculate the extra. What helped me was relying on merely reaching the point in BFS is not enough. You have to take care of the direction. Hard time. I tried a couple of things, but the most approachable was a recursive solution where I used Dijkstra to find the lowest cost to get to end. Then is recursive to find all possible solutions have the same cost as the mean cost found by Dijkstra. This works for the test input. There's a big runtime issue with the real input. There is a way to modify Dijkstra. Oh yeah, I could just return the cost. And just do BFS until I find another way. Yeah, but my algorithm doesn't find this. Like, let's try it even over here. See at least if I get it, some of them working. Like in this case, looks like it would work. So any export points with the same cost is an alternative path. Fortunately, my input does not have a fork road near the endpoint. It isn't. It will have converged before it completes. I use the list to store the next path to explore, and after each iteration, I do some cleaning up duplicates. Use a list to store the next path. The other thing is my G-score does not have. My G-score does not have any possible way. I'm not finding. Like I do find something that are close to the end. But I don't have 2 times 7036. Pretty sure because I can always grab 7036. Yeah, see, and that is basically once. Which is... I mean, what I would expect it to be. So that must be... Like, this must be the problem, right? But what instead of carrying the path inside the cane from? I would carry the path inside... if not a G-score, it could be... Yeah, well, instead of the G-score. Because right now, there I'm carrying my direction and my score. And if this carries also my path, I can just say at the end, hey, give me the path. Let's see if there's any difference if I explore everything all the time. Looks like there isn't. What about the visualization of this? Wait, I'm grabbing, my bad. So that doesn't really change anything. Now the F-score, I remember changing my answer if I'm removing it. So this is bizarre, but at least now I'm exploring everything. And sooner or later it stops. Also, instead of printing this, let's just run it nicely and see if I explore more stuff. Doesn't look like it. And I only hit it once again. Fortunately, doesn't have a fork. It is to modify the extra. Going to keep exploring path when its cost matches the lowest cost already seen. Only Abaddon path with higher cost. I likewise at the end I don't stop the first time you pop path ending at destination. Keep going until the cost starts going up. Now that I think about it, maybe I understand the dude that added plus 1000. Because wouldn't adding 1000 fix or 1001 fix some kind of an issue? Like the idea over there would be that theoretically speaking, wait, what? All right, because this is infinity. So that won't quite work. But yeah, if it's not infinity, because I'm adding the max value over here, right? Can I even check if there's an overflow so I don't get into that issue? Like if I'm adding more than this stuff, if I'm getting more than 1001, this should be able to help me out. Yeah, but how do I check if this is infinity? Wait, I hit 2? They print it twice, or do I hit so? No, I printed twice. Yeah. There is something to the idea of if the tentative score is less than this plus 1001, but I should be adding this only if the score is there. Because I could consider this like the infinity. I could use none as the infinity. Well, first of all, let's make it in a brain dead way. If this motherfucker is different than USIDE's max value and tentative score is less or equal, then G-score, whatever this motherfucker, mu1, then we put all of this, and at the same time we will add plus 1001. Doesn't change anything. I can see what I wanted to do. I want him to take alternative ways and keep going. Let's like call it kept. This way I know what does get dropped. So I'm fine dropping those. That's not a big deal. Like dropping all of this. I'm guessing that should be something closer to here, like this 3009 all gets dropped. Is it too high to keep everything? Yes, it is. My lord. Man. I could also print the map, and this should be some cool stuff to be seen, right? Oh, wait a minute, so I keep a lot of this stuff. Yeah, but if I add plus 101, this gets fucked up so bad. Like one thing that I would like to know why it goes up, left, but not right. It never tries the right. Oh yeah, because I have to do a couple of turns. No, it should be still one. Like if it goes left, shouldn't it go right as well? Okay. Parental list for each node during Dijkstra. Yeah, the problem with that is I don't always work. Also, I don't even know how to construct. Okay, let's give it a try, but problem with that guy over there simply is that I don't explore some of the paths. Like supposedly, but only supposedly. So by the way, I can't just return because it doesn't really matter if I keep going afterwards. That's not the point of the algorithm. Okay, so supposedly I should do this curve and I should do this curve, but I don't even try to go up and I try to go left. So even if I get every single possible trip, I would still not be able to go again. I still want, like I have a couple of stuff that I miss. And as we tried, even if I remove this, still won't work. Then it must be my neighbors, right? Like I want to know what happens at this point, in this specific, when this is the current, which I don't know if it isn't ever the current. I mean, theoretically, it gets pushed. Okay, so should happen. This guy should generate two neighbors, right? Theoretically speaking. This guy over here at some point should give me two neighbors, and I should explore two neighbors. So the point is 12,4, either it's 11,4. And when I get the neighbors over here, if current is equal as 13 and what was it? 13, 11, 11, 3, then print neighbors. Okay. Very well. Also, we can print each tentative score using the same logic. So 305, 405, 205. All right. The best one would always be of course, the 11.4 because we're going forward by 1. Makes sense. 2005. Why is 2005? Yes, 2005. Very well. If we go up 11 su, that's 4005. No, okay, if I'm going up, that's 3005. So that doesn't sound terrible. And I'm also going to print a kept over here. So 3005 does get kept. Wait, what? But this isn't what I see happening. Might it be because I don't do this? Okay. All right, so I do get to explore everything, which well means that let's mirror how my G-score, I call it paths, which should be a hash map of chords and a vec of direct, rather than direction, a vec of coordinates. And we hash map new okay. Path dot insert, god damn it. Dot insert and will be start vec with start over here. Basically, every time that I'm pushing a node on the G-score, I'm pushing them even there. Paths dot paths dot entry nay and modify f dot push nay or insert nay, rather vec of nay. So this shouldn't bother anyone really. I should have the cost for that path, shouldn't I? Amazing. Wait, because I'm returning. Oops. Of course, makes no sense. Right. Yeah, again, doesn't make any sense. Because every time I increase the score, I add one guy, so I guess I should be pushing the current rather than the neighbor. But this happens specifically only once, so we're not in a better luck, to be honest. This looks slightly better, but again, I don't see like full paths over here. So yeah, I'm inclined to just BFS it, get every possible path and then see what happens from there. So right now because I don't have the paths. So now I want to get every single way in which I get there and measure the list. Oh, okay. So it's odd time. Yep. So I'm gonna go to the bathroom. See you soon. Okay, looks like the ad is back. Oh, by the way, it's almost time to check on my servers. And also I need to pay on so let's pay my landlord. Let's check on my servers, and then we go back to it. Honestly, I'm stopped because there's a lot of stuff that gets me problems. Like a lot of stuff. Alright, so step one, got them. Step two, on my way. Problem is, I yet to understand how can I calculate every possible way to get. Like the only other way that I can see it is BFS any path. Like if I BFS, I should be finding any possible way to get there. And after getting every possible way to get there, I just calculate the costs and keep the smallest one. Honestly, that's easy, that should work. Now, personally, I'm very upset that people are doing it somehow with A star and with Dijkstra modifying them. I just don't get it. So I'm not gonna spend any more time here. Yeah, I'm just gonna BFS it. BFS, get a path. Every time that you find a path, save it. So for each path that I'm going, I'm just gonna save it. Get a list of every possible path. Then after every possible path, I just count to see how much it costs. And keep always the minimum. That should work, right? Okay, so everything is fine. Okay. Now makes me wonder. So if I BFS this guy, so I in queue, mark as widget where queue is not empty, remove the queue, process all the neighbors, and if it's not visited, in queue and mark as visited. Okay. Obviously, this doesn't get every possible path in a graph. This is the problem I want to solve. Oh, for the weighted version, you might want to use uniform cost search. Left is my dice calculated on the solve part 1. At is Aussie's first example. The problem I have is the cells make in red. The Aussie's is on any of the best path by is opposite. Visiting the yellow path because it doesn't be visible, therefore the red path is not optimal. It's southern path to the red cell. Just go up there 2 cells and you have the same exact score. In the pre-running conditions also continue about were 1,000 apart. Man, you saved my day, thanks. Okay, so that's the shit. Like this is the shit. But problem with this way of thinking is Rust. So let's reset again. Okay. And let's try to solve this guy. Actually, I would want this neat visualization stuff. It's the only thing I need. Okay, the pre-running condition. All right. Okay, if I had it as follows, I guess instead of putting max here, I should put like something of like let's say 50k. Okay, this will work the same because 50k is essentially infinite since my biggest solution. Okay, and at this point, I am just gonna say plus 1001. Or the other way around. Either way, it doesn't work. Okay, so it was 1,000 and so let's say. Yeah, let's make it for good measure 3,000 and just be okay with it. Okay. By this point, do I have more stuff to grab? All right, I don't print anything there. Still only once. But at least I know with the current I always hit it. So I do hit everything. But one thing that I'm guaranteed. Like one stuff that I'm guaranteed to do is that now with my current I actually hit and see everything. Which means I should be able to do something right now. I'm still kind of surprised that my costs don't get. Yeah, I'm still a little surprised that my costs don't. I don't see not one more kind of direction. Like that. How about if I backtrack? Because I have the history of every possible way in the came from. Which makes me believe that I should be able to use the, now that my came from should be complete. Theoretically speaking, there must be a way in which I can reconstruct every single line. So starting from my Nord 13, I should be able to reconstruct every single line. I can run reconstruct in every possible direction. Like let's say one forcation is here, right? The usual 1114 or 11.3. So there are a bunch of 11.3s. So there's one here that leads you 11-2. And there's no, there's only one. Yeah, it does get used later on. God damn it. Yeah, this isn't still it. This might be the time to remove this guy here. And just pick either the first one or the last one. We're gonna need a bit time now. Let's start with 0 first. Let's start with pop and wrap second. Okay, so this happens to go this way, huh? Okay, I see what's going on. So yes, I'm hitting everything, but at the same time, there's only one predecessor of 11.3 and it goes only in 11.2. So I'm not even rebuilding anything because this is only one path. But at least now I know I'm touching everything, so that means that I can generate every single path somehow. Like if I go backwards from the optimal, you know, so every time that you go backwards, when I go backwards, can't I run Dijkstra backwards from every node and get the cost? Okay, I can do a backtracking algorithm. Basically, I could iterate over each one of them and run a Dijkstra on. I'm thinking about the idea of running Dijkstra, or let's call it Dijkstra because E-star is harder to pronounce. How about a Dijkstra for every direction? So like when I get here, I know how much this cost me. And I can Dijkstra over here plus the cost that I got. And that should be able to give me the correct portion. Because now it's purely me not being able to reconstruct it. There's one tiny piece of correction that I don't have. So the best path. On some examples you see it, but I'm trying to get only one path. For example, want unified paths till proof your implementation. The turn on a device doesn't get a button chance to reach a processing point. Not right, I went to it. Thanks. You can still, but you need to either handle the case or returning more as two different operations. I've seen some kind of solution that find the branching path is different using that, so make it once. Yeah, the only way that I see this being feasible is, let's say that I run Dijkstra for every single node, for every single neighbor of the optimal path. So this is the optimal path, right? Let's draw it up. So I find the optimal path. No, something like this. See, there's a U like that, and then there's tac. God damn it. Tac. Some shit like that. And each and every node has a cost. Now, how about I make a Dijkstra from here and see how I get there? And if I'm summing whatever it is here plus whatever is there, that should give me if this is an optimal path. And same goes from here and here. Basically, it's the same, so keeping the same algorithm. The only modification is I would need to know the partial cost up until there. So I'd want to also store how much it cost me on the path. Yeah, that should work neatly. Okay, this gives me some semblance of hope. So let's reset again. Okay. So I return the reconstructed path. And inside the reconstruct path, I should probably want to adapt. what it feels that I want is okay, so that's my path. So it doesn't let me verse it. Okay, so there's the path. Now, using this path, how about I make a function? So let's make a function that will calculate this cost, which I know which one would be. The same function that calculates this cost. Then I'm going to use the neighbors. Rather, a function that gets me the cost at each step. So that this function would be a coordinate and the cost so far. The cost starting is 0. And then I add up each cost. Afterwards, each function should be able to do. I should be able to run partial Dijkstra on the neighbors of the best path. If those neighbors are an optimal path as well, then we're good. Also, there's no need to run it on. There's no need to run it on something that's already in here, because there's no point to running Dijkstra that. And this way, I should be able to run a Dijkstra from here, and this will give me one optimal solution. A Dijkstra from here, and that's about it. Okay, that's something. First things first, let's make this into an optimal. I mean, I can probably get it very easy to work if I can I use the G-score to do it? Makes me wonder. I believe that G-score should be able to provide that information for me. Man, I have stuck that Billy Brown card meme in my head. It's so hard to reason about things. What's Billy Brown surname? Nope. Stranger Things cast. Bobby Brown? What's her name? Bobby Brown. Millie. I swear, man. This.
But these are great. You know, these are great. The dirtier, the better.
I swear, man. I need to uninstall Instagram again. My brain is just flooded with this shit. Okay, so let the TMP equals this. Okay. Clone it. I don't give a shit. Okay. Let's run over. So for L in TMP, let's print L. That's the first one. And if let sum cost equals gscore.getL print cost. That can be adjusted. All right. Cost at 0. Might even need direction. Okay, wonderful. Okay, so this is the first part. I would also need the direction, so that shouldn't be a big deal because if I do it this way and simply print the 0 and 1, display doesn't fuck off. Okay, I also need a direction, which would be okay. Why is it going down? Did I invert it up and down? And left and right? Feels like I inverted up and down. Like if I'm clockwise and I'm going up, clockwise, then I'm going right. So the clock works. Clock. So yes, clockwise. I'm going up, going right. Else I'm going left. If I'm going down, going left, and counterclockwise is right, then up and down if I'm left. So left is up or down, yes. So the logic is sound. So if my direction is up, don't know how does it even work because you keep going down, everything is inverted. Like I'm starting from left and I'm going down. Fucking down. How's that make any logic. Honestly, I don't even know how my logic works correctly, but sure. I mean, if it worked up until now, it should be no big deal to keep working. Okay. Now I can just zip this up and return it as it is, because I care about all these three things. And now I can run Dijkstra without much of a deal. The only problem is I don't know the starting direction, because I assume it to be left over here. But this could be passed as an argument, so that should work itself out. So this should be a vec of coordinate, cost, and direction. Or the cost is a u size. Yes. And while doing this, let return, let res is going to be a vec. And res dot push. Okay, and that would be first off the coordinates, that the cost. That's 0 and cost at 1. Okay. Then return res. Z. Res. Of course, it has to be immutable. That's right. Very well. Puff. Or L. Wait, isn't it the print the problem? Probably the print. No, it's not my custom print. Pretty sure it isn't. Up, down, left, right. Okay. I have a logic problem. But my logic is perfectly inverted, which means that it doesn't... It's not a problem. Okay, that being said, now I have everything I wanted. The next thing is to correct the initial direction. Problem is that I start with left. Okay, now I'm going down and down again. They mismatched it because no, this is up, this is down, this is right, this is left. Oh, yeah, I forgot about this. No, I solved this problem because I clone it and then I only move the actual dir. Just fix it with the actual dir. Do I change the actual dir somewhere? It's left, right, down, up. Fascinating. Anyway, hey, until it works, it works. Problem is I think it might cause me some problems. I'm afraid it might. So there is a direction, yes. And I can say dir this way. Then it will complain that there's no dir here, and I'm gonna say direction left. This shouldn't change my outcome at all. Very well. That being said, I can always just no, it bothered me a lot. I don't know how this happens, but it does bother me a whole bunch. Do I push the incorrect one? Like, what's the big deal? Over here. Current direction is current score 1. Current score is user direction. No, I use always the current direction, which is the one I mutate. Honestly, I can just opposite it. I can just take the opposite and run from that. But whatever, let's move it up. At this point, for each and one of these individuals, I'm gonna find a neighbor. I'm gonna Dijkstra that neighbor. I'm gonna A star that neighbor. The A star of that neighbor will return the same path or the same idea as this. And my last, or my first, I guess. So my first target will have the result that I want. If I subtract this, okay, let's save also this. Let optimal is going to be path 0 dot. So we have 3 of those. Yes, not 1. Okay. Optimal and type. Okay. Great. So we have the optimal. We have the path. Now I run it every time, check the optimal and see if it's. I check that my optimal, that optimal is equal to the optimal minus the current score. And that would give me an optimal on itself. Yes, yes. So the neighbors, I have the get neighbor. Very well. So for each one of those, how about I get the neighbors, and for each neighbor I do that. Okay. Let neighbors equals get the neighbors. Here's the map, and the current is L dot 0. Okay. God damn it. Man, oh man. Okay. Now for each neighbor, for in neighbors, if path, I don't have the single path or only coordinates. So that wouldn't work, right? Let path equals a back. Okay. For node in path info path dot push node dot one. Whichever one the empty path. Path dot iter. Okay. At this point, when is my next ad break? Okay, I can hold it for 3 minutes. Afterwards, we can go to the bathroom. Okay. So, rich neighbor, if path dot contains the neighbor, then we continue. We say fuck off. If we don't, the fuck. Alright, I need a 0, 1. Maybe I can't hold it for 3 minutes. No, I can. I'm a big boy. I can tolerate it for 3 minutes. Okay, so if it contains, very well. Otherwise, we would want to run an A star. Let TMP equals A star, and the goal is always the goal. The start would be the neighbor. The direction would be the name.dir, the la.dir. Okay, there's a slight problem. 140, goddammit. Okay, there's a slight, tiny, teeny problem. I need to calculate the direction on which the next guy would fall. So it will mean get the direction on which the next guy should fall, and also get the cost of that guy to keep up. Because if I started from this optimal route, it does not work. I need to get the can I apply the distance? What does my distance do? So current, nape, and dir. Yeah, yeah. So if I apply the dist, I then will have the correct direction, and I will get the correct cost. Do all that, and so get the correct direction, get the correct cost. Then moving on, I'm going to have to add this cost, that direction, and everything else. Goddamn, add starting soon. Okay, the say, however, is not telling me anything. Well, since the ad is incoming, I'm gonna leave you for a bathroom break. See you in a couple of minutes. Okay, so we're back. In during the break, I solidified what I say that my hypothesis is. Okay, so we were saying that you would want to, I would want to, if the neighbor is not contained, I want to run my A star on that. But to run my A star on that, first I'm gonna use the dist to get everything that I would need. So let tmp equals dist, and for this to be the nei or ele, the nei and the dir. Or rather the ele dot 0, which is my coordinate, and I don't have a dir. The dir would be the ele dot 1, which you wouldn't want to modify, so let mute dir equals ele dot 1. Make capacity mutable. So ele dot so is the direction. Okay. By this point, there's this u size, which would be the cost that I need later on. And let's say one cost. Yes, yes. We can also call the let cost until now, and that would be L.1, I believe. Then we can run the A star. Partial. And that would be the map. The start is my L.0. The goal is still my goal. Wait, it's not the L.0, but it's the next one, which is nay, the goal. The dir is the dir. That's correct. And finally, I think, well, let's take a look at what happens here. That looks like it runs like butter. I would want to do what we said. If optimal is equal, so partial plus one move cost, which is the one. Isn't this like a u side? Yeah. Wait, the partial is not a, okay. So cost until now plus one move. Dude. Oh, that's why. Let one mute one move cost. Println Gadam. Oh, and of course the partial, which we don't have, god damn it. Let mute partial equals back. Partial 0.1. Okay. If partial is empty, then we can continue. Okay. So looks like this is happening how I intended, because it's two optional paths. Now at this point, for node in partial, if path doesn't contain the node, then path.push node. Not at 0, then we push at 0. Yes. Count of nodes. And that would be my path.len. Got them. Excuse me a second. Okay, so this is the 45, which is the correct response of part 1, or the input 1. The second input should be 64. Okay. And the puzzle input should be, I don't know, we gotta see it. 576. Can I use again 576? Cat add outputs. Huh. Is it 64? Let's see, perhaps the problem is figures. Yeah, so the path here is optimized. And the buff here is also optimized. But I'm guessing there must be some kind of problem with my output. Five, seven, six. Did I by any chance write it wrong last time? So if you're stuck, make sure you're the full input data. There are also general tips on how to win a page. Now, one crazy thing that I could be doing is to just check manually if it looks like it only gets one buff though. Oh, here's a bifurcation. Yes. There's a bifurcation over there. That's unlucky. Guess I should be. Yeah, I have to try and see what the problem is because this looks fine to me. Okay. So either I'm very unlucky or I should search from some condition because at least now we did some. It was gimmicky, but it did work. One thing that I find might be hilarious is like it's an off by one or something. Or we can get some easy manual intervention somewhere. Like, yeah, if something like this doesn't quite work out, no? Because a completely vastly different way shouldn't quite work. Oh, this looks like fairly the same. So that should be a +3, possibly. It's a possible iteration. This we eat. This is, yeah, because we actually no, because in this case I only do one row, but in this case I do once here, once here. Like this is not it. Here looks nothing like it. It must be plus one or two different ones. It must be very, very little. Like some way of this. So we go fully vertical, there's nothing there. Honestly, so I tried 5, 7, 6. How about 5, 7, 9? Still too low. So there's it's considerably bigger. Okay, day 2. So day 16. This one, alternate case test. You should prefer to take the long zigzag, blah blah blah. $149. Is my algorithm wrong? Like, does it work? Like one cheaty way in which I believe could be solved, but I don't see any immediate, unless there's some way to get there which is way more optimal than this, or some alternative way in which is optimal. This should be fine. Like, let's try adding 100. So instead of 5, 7, 6, how about 6, 7, 5? Okay. Okay, so it's 6, 7, 5. How about 7, 6, 5? Okay, so he already won't tell me anything. Yeah. And we're fucked. But that's for tomorrow if I don't solve it beforehand. So let's just raid someone and go about our day. Same category. Want to know how many people are there? 1. So raid. Same category. Why can't I just go also same language? Well, thanks for following today. I will see you tomorrow. Hopefully, I'm finishing this anytime soon. Hopefully. Bye bye.